Hi, I'm Alexa Schmitz. I'm a co-founder of Regen. My co-founder Sean Medine and I are both currently working in the Barstow lab in the Department of Biological and Environmental Engineering here at Cornell. And the technology that we are developing for our company is all about finding rare earth elements in a more sustainable fashion using biology. So when I was a kid, I actually lived in an area with a lot of nature. Open land that I could go explore in. I really had a lot of freedom to go out and do whatever I wanted. My parents let me roam the woods, build tree houses, and in a way I was even inventing then, coming up with new ways to play with what nature was giving us. And I think that's a bit of what I'm doing today. I'm really working with what nature has given us and trying to turn it into a solution, and it's always fun once you're inventing something. My technology uses bacteria to address this problem of trying to have a sustainable and reliable source of rare earth elements. My particular technology is using bacteria to extract rare earth metals and other metals from a variety of sources, solid sources. So anything from crushed up rocks to crushed up cell phone debris and waste. So normally rare earths are extracted using pretty harsh chemicals and high temperatures and pressures, and this can have an enormous impact on the environment. So rare earth elements are critical for lots of sustainable energy infrastructure. They are a big part of windmill turbines. So when you want to talk about creating widespread sustainable energy that would give electricity to the whole world, we really need to think about ways to make this cheaper, sustainable, cleaner. And if we're putting so much energy and creating so much waste in the production of the rare earth elements, then it almost negates the point of the sustainable energy itself. So by coming in with biology, what we can do is create a really clean and much more sustainable system for getting these rare earth elements out that would basically support that idea of clean energy further. So when I first met Buz, he presented this really, really cool idea. He wanted to use microbes, bacteria or fungi, in order to extract rare earth elements. And actually, to be fair, it wasn't his idea. Some of the best work is coming out of Idaho National Lab in David Reed and Yoshiko Fujita's lab. And they demonstrated a really nice example of what we call bioleaching, which is biologically leaching rare earth elements from a variety of recycled and waste substrates using a bacteria called Gluconobacter oxidans. This is kind of my special bug of choice, and with their support and help, what we've done here in the lab, and this is actually where Buz's idea comes in, is that we've used genetics to better understand and explore exactly what allows Gluconobacter oxidans to be able to extract rare earths. And in doing this, we've identified some critical ways that we could modify the process in order to improve its efficiency. Previously, the Idaho lab actually did a techno-economic analysis, basically looked at could this make a profit, and there is some margin of profit available according to that analysis. But we came out and said, okay, well that margin might not be big enough for a company to really want to pick it up. Can we use genetics to figure out how to make it better? And remarkably, it's been an exciting ride. For the past 4 years, we got a lot done. We created a whole genome knockout collection. Basically, we were able to make a strain of bacteria that had one of each gene knocked out. And by doing that, we could screen to see what are the genes that are contributing to this process. With that work, we were able to publish the knockout collection and what we found in the genes underlying rare earth bioleaching in Nature Communications about a year ago. And then we identified the ability to use those genes either by getting rid of them or upregulating them in order to improve bioleaching. And that we disclosed to Cornell Tech Licensing and has eventually turned into a patent application. So now it's out there and we can actually use it for real world problems. And it all comes around in the end. I've had so many mentors in this process who have been incredibly supportive, and I know that someday, I hope that someday I will be one of those mentors for other entrepreneurs, innovators, researchers, anybody who needs to understand the process and how to just put one foot in front of another. I see it now as my responsibility to give back to the next generation. And I really hope to be able to support women innovators going forward as well.